Good morning, everyone. Welcome to this presentation, Thursday, September 19th, 2019. Got a presentation that I've outlined, and I just want to start off today's presentation. Hey, Jason, good morning to you. Thanks for coming. I just want to start off this morning presentation about luck and what luck is. And to me, luck is preparation, and we all preparing to do different things in our art, state of the art, with the devices that we have envisioned. And as we prepare, we're going to be meeting opportunities, and the opportunities in this field being brought back to basics and what's really going on, and getting it from the complex to the simplistic. Today, I really want to verbally paint the picture that is the springboard to tap in to the monopolar magnetic field. And being a chemist, to figure out all the effects of the different chemicals and everything, got real familiar with dipole moment chemistry and understanding the vector of the longest unit had the most strength as far on that end, the most influence, magnetic influence, if you will, in dealing. Not that I have a magnetic personality or anything, but the monopole is the quest, if you will, for the Holy Grail, especially in magnets. And as we're getting it all boiled down to is, okay, we've got ferrous material, metal. The thing is when you're dealing with metals, you're actually dealing with composites. Wrought iron has very little carbon, for example. Okay, and carbon is what actually causes oxidation or rust. So the fences, if you will, that were made of wrought iron, time tested. I mean, they last for a long time. And so many of the things that we say, well, this is iron, this is steel, this is ferrous materials and everything. The most of the stuff that we garage chemists deal with is dealing with composites that are already made up. And then in different forms that I've done, couldn't find the exact chemical I was looking for, so I had to extract it from things that were out there and come up with the processes to do that. And so one of my favorite toys when I was a child, I'm talking about 2, 3, 4 years old, was a record player. And especially being able to put that record player in neutral and run it backwards and hear the voices go backwards and run it slow and hear them go real slow. And then hear them speed up, and then running, at very slow speed to hear everything, and different frequencies that were in that, but yet it's in the same record and how it's being played, the vibration that came off of that. And so if you think about it, the outer layer of the record from the center, it's an analog spiral, if you will, and one of the cool things about a record is that you can actually take silicone and make a record out of silicone, and everything that's on there transfer over to the silicone, if you will. Okay, so the making molds and things at that point. But the importance of the simple find that Roy got us back to with the Model T Ford, the spring-loaded spark gap, the kinetic energy, if you will, sets up the premise, if you will, the building blocks to get us to look at very old technology and bringing back and understanding the possibilities of creating the monopole ferrous material. And that's kind of like the little quest for the Holy Grail. When you look at people present a monopole magnet, there's really no such thing. However, with the monopole design, we can get close to it, but you still have that dipole that's in there, that tension, that strength, and that's what we're really tapping into as a leverage in the vectors of 90 degrees, and then finding that 45 and making that lever operate back and forth. That causes that amplification. So the longer that lever moves out and telescopes, if you will, even though it's happening there and it's moving in that area, the reflection is we get that longer and faster, just like a golf club. It makes a hell of a swing, and that's really what we're searching for in this asymmetrical configuration that we use for emergency generators, and understanding how emergency generators are wound differently than grid type things. So one of the things I want to clue people into is progressive resistance of the inductor. And ideally, it always comes back to fluid dynamics and current. You have your big pipe, and that's the current, okay? That's the flow where there's no pressure. That's the kinetic force of current, it's just slowly going through. Then high pressure being the small line, really small, how small is small, but the resistance and that pressure and using the force of the current in this valving. So here you have a big water column, and then here you have the current vector, and that 45 getting that to oscillate and work within that current. That's what we're working with. So you're dealing with hydrodynamics, and then also you're dealing with another thing, and that'll segue into my next part of this presentations in the future. I'm going to do a wrap up, as I promised, of tying all these 6 things that I'm talking about and get a simplistic wrap up as quickly as possible. But still, there's a lot of information there to paint that picture. So the different cores that we always work with, whether it's hollow core, whether it's iron core, whether it's ferrous materials that are composited together to make that. The other solution is with transformers is actually building the capacitance into the transformer. But getting back to what I was telling you, if a circuit, as far as dealing with inductive coils, instead of putting a resistor here, whether it being 6 ohms, 15 ohms, 20 ohms, 30 ohms, whatever, the cool thing about alternating DC pulse width modulation, those types going through, really, to me, the only difference in alternating current and pulse width modulated current is where you ground it. Okay? And so on the generation side, we're looking for pass-through and pass-through amplification, and not grounding all the terminals like you would in a balanced system. But the wire itself, as you run more feet, the resistance gets higher, and you'll find in North America that the motors pretty much work at 6 volts. I mean, six ohms. And so in the bipolar field, what that's going through basically calculates out to 60 volts. Okay. Especially if you're dealing with opposite phase in that, it actually acts as a transformer itself running through the 6 ohms, and that's balanced. Okay. And so the Bedini taught us how to unbalance the load. In other words, whether you're putting, starting off with 50 ohms, 75 ohms, running that through a variable resistor, as we tooled up and really getting the currents up with the series side of the battery equation. That's the high pressure side. Okay. And so with resistance, we could take the amperage out of that and actually allow the amperage side running through the bipolar transistor to pick up and make a stronger motor because it was making a magnetic field. So it'd go from low frequency to a high frequency, and then it would tap in to the parallel side of it. And so you could actually, just like flipping a switch, develop a system within itself. And it worked just on 2 12-volt batteries. Okay. The system in the PMH, when you just had 2 batteries, was actually operating at 24 volts. Okay. Thereabouts. But when you start putting in series and getting the configuration that I showed you, and understanding that in that you have a loser battery, and then you can recycle that through the system. Like I said, it still runs down, but in the ideal circuit, we learn how resistance does that. And when you do the calculation, it's really amazing. The pig pole transformers and everything else work on this, but if I can show you this diagram that I drew up 2 diagrams, and it all goes back to Ohm's Law. Okay. So you have a 120 volt, 60 cycles, and you put a resistor on this side that's 6 ohms, a resistor on this side that's 6 ohms. Off these 2, you're at 60 volts. And off these, you're at 60 volts, although you have a bipolar unit through there. And in the generation, the bipolar, to capture this energy that we're looking for, as long as you balance those 2, I mean, they can be 75 ohms, but what you're going to do is stop your amperage. So that's the reason the resistors in series and not in parallel with that. So you can have resistance on one side higher, the other side that's lower. But I want to make that clear that yes, the resistance can raise the frequency because you're slowing down the amps and you allow that to oscillate through the transistor. Well, the same thing is, although I haven't played with it as like yet as I want to, but I'm working on building my solution and my state of the art on how that works. But the core, whether you're dealing with hollow cores, iron core, dielectric bias cores, the composite fair cores, or the combi capacitor in all that, you have a lot of different solutions and tools in your toolkit that you can come up with to work with those designs. One of the cool things is that understanding that through different techniques, you can actually make the fuse the resistor. Okay, and you can, if you can put things in it that'll actually blow that fuse if it reaches too many amps for whatever current that you're working with. Now I want to separate the difference between the earth ground and the chassis ground. And being a farmer, the wells that I work with Waterwells, they're 120 feet deep or so. And so you had a big line that went down to the foot valve, okay? And then you had a small line that went down the foot valve, okay? And so the small line, after you primed the system, was the what came up to the top, and then it would go to the bigger line, which gave the gravity drop of current, okay? And so the motor could easily pump, in that Waterwell technology, a 1/4 horsepower motor could pump plenty of water and pressurize it in the vessel. And so again, you're going back to what's happening, but the foot valve, if you will, is actually the diode in the system that I'm describing. So it's a lot cheaper to, if I drop just a line and have a suction pulling that water up 120 feet, it takes a lot more power, a lot more energy to do that. I'm talking, 120 feet, the heads of pressure take about, 5 horsepower to do that. Okay, so what do you want to spend? Do you want to spend a 1/4 horsepower to do that, or you want to spend 5 horsepower to do that? Okay, over time, cost of energy, load factor. So I've saved a lot of people money in irrigation just understanding the basic principles of hydrodynamics in working with what's in the ground, okay, and how to bring that up. Kind of like a side note, one of the pumps I designed for irrigation actually uses air to do the lifting, and a lot of things happen the same way. So understanding the lighter particles of what it is that you're trying to influence, the whole thing comes to just like a hot air balloon. You fill the balloon up with hot air, it'll pick up 400 or 500 pounds, no problem. And a lot of BTU go there at once to heat that air up in there, but you can control your altitude with how much hot air is in the balloon. And so when you're talking about gravitation of different things, lifting, getting away from Bernoulli's force and all the other things that you can add into the equation, that's really all you're doing is you're either super cooling everything beneath your feet, which causes levitation. Okay, that's super cold. You have a lot more pickup. So what happens when you develop the right circuitry, the right coil, is convergence and divergence. Okay, and so anybody that knows anything about aviation, especially carrying heavy loads, knows about density altitude. So on a hot summer day, Airplane will fly, but it's hard to climb. It's hard to get altitude. Cold day, in Alaska, manned planes, let me tell you, they just almost like a rocket. They'll go through. And then you have a lapse rate of pressure that actually cools. So you understand that lapse rate as you get higher in altitude, getting that cooler air, it even flies better. And so a lot of the things that we're doing with the understanding the parametric oscillation and the adding the asymmetrical component in there, we have the ability to magnetically create cooling. Okay, and so the cooler you get the material, the better it works because of the density. Okay, and so, but you still need a high side and a hot. You still need your cold side and hot side, just like you need refrigeration. You still need pipe, either large to small or lots of pressure that the current leads voltage and sends off on those two vectors. And so what we're trying to do is pull that 45 and just, catch that oscillation and go through. Still takes energy. I'm sorry. It's going to come from somewhere. You don't get some from nothing, but the better that you do that, when I saw the solution that Roy gave us, by taking apart the Model T Ford spark coil, understanding how it was wrapped, the magnetic field, but the overlooked thing was a dadgum spring loaded. Okay. And the adjustment spring to do that, to bring up that kinetic energy, to make that monopolar biased to one side off that spring. And so pretty cool stuff. We can do it electrically, but to really impart that knowledge over, that's all that's happening in there. Now, I want to bring something kind of back, and the parametric side, the parametric oscillation is really nothing more than plasma. Okay, but that plasma can also be biased, and so the parametric oscillation side of it is the plasma and the biased plasma that's in there, and we can quench it and use different materials, everything from water to oil to other dielectric materials, Teflon, to do that as far as the separator. But getting back to the earth ground and chassis ground, the chassis ground has very low resistance. Earth ground, depending on your part of the country, has range, if you drive a rod about 4 foot into the ground, pretty high resistance in most part of the country. You can expect somewhere around 300-400 ohms. Does it make a difference in the system? When you're dealing with RF, which is the 7200 RF that comes from the facility, not really. Okay. When I was in radio communication and building towers and putting tall units up in the air, the companies I was working for, you think you'd ground the heck out of those things. They say, heck no, we don't want to ground that antenna. That's going to make lightning strike it. Okay. So if you wanted to promote lightning in the system, you just grounded it. And but we were working with dipole type antennas and with frequencies of their own. And we actually grounded it just before it went into the equipment, so it would choose to take that path if it got struck. But we didn't want to promote that whole tower being struck. Lots of code has been misunderstood through that, just like aluminum light poles and stuff. They grounded them. Now they're finding out, no, we don't want to ground them. Dog come up to an ungrounded unit that had a short in it, and the urine traveled up and killed the dog, supposedly, but lots of controversies of where and why you ground equipment and understanding the difference between earth ground and chassis ground. One of the things that's cool about 6 ohms, for example, you can expose 6 ohms to a potential of 200 amps, and it's still just going to draw what it's going to draw, right? So the 12 ohms, same thing. 15 ohms, 20 ohms, 75 ohms, 100 ohms. You're going to lose that heat in the resistor, but the same thing happens with the ground. When you get the ground rod down 50 feet, you can get your ohms down to about 50 ohms. The earth is supposedly, or earth ground, technically is 0 ohms. Okay. So getting to understand the electrical code with the earth ground and what you're doing in that segment. I want to back up of what I misunderstood. 1 square mile concerning capacitance as being 1 farad, that's 1 wire, a thin wire, and the gauge of that wire has not been discovered yet. So you could have a network, if you will, of wires going, and that'd make more farads. I took it as being the separator because I've seen at power plants where they put separators in between the different piles and basically had a huge capacitor right there at the unit, and they keep those piles there. They think that, well, we need it just right there, but yes, they do. But okay. So a lot of these people work on this equipment. They have really no idea of how it all works. They have, a working knowledge of just needing to know what they need to do. And the same people at wiring transformers, they have no idea the composite wire that they're actually wiring a transformer with. They have no idea. They call it electrical steel and silicon based and everything. So getting the material in the right mixture for what you're doing to create this electret, okay, which electret's been right there in plain sight with batteries, transformers, and you build this bias electret into where it's polarized off the anode and cathode to where it tends to want to go the direction that it was designed to go in. And it's just like, I'm going to take my hand and go counterclockwise right now on the screen, okay? But when I play this presentation to myself, is that going to look clockwise or counterclockwise? Okay, now I'm going to stop and go clockwise. Is that on the other side of the mirror? And this is getting into the mirror reflection of the parametric oscillation through the plasma that creates a capacitance of a mirrored reflection. And so getting to understand that plasma and how it converts over is what actually creates the open system as opposed to the closed system. And so when you're dealing with an open system like we discovered yesterday, and I was right off the top of my head, my math when I'm talking sometimes doesn't work, but I'm a very good mathematician and I have all this stuff stored in my brain somewhere and I just can't get the right department to get there and do it. But yeah, the transistor that I use, 15 amp, and I operate them all the time at 1,000 volts. So a lot of kVA there, and then to think how much it took to blow that sucker up just off a coil. So you're tapping in on an open system to a lot of energy. 15,000 watts is what each one of those transistors can tap into. So in getting that done is the PMH leverage and the 45-degree telemetry is what we're working with, and figuring out the biased electret with the anode and cathode in the mirrored reflex. And we can work with divisions subtractions and additions of polarized and ferrous materials within this construct, building a lot of different choices, giving us lots of latitude, longitude, working with all the dimensions within that polymerized material, composite. Like I said, I saw a long time ago that I could build batteries right into the boat just by taking an extra step, because I have the polymer itself is non-conductive, and so the thinner I make those laminates, the get that separator down. Now I've learned how to penetrate the separator, make it porous, and actually build the electrolytes, if you will, right into the unit. Is actually more considered a ceramic battery. And like I said, I put the materials together for the battery, that what I consider would be the ultimate battery, and I got some coming in, so I'll be demonstrating those when they come in. The getting the understanding of your Y and delta pass through versus balanced systems, and those vectors of what you're doing, you can get a mental image of it, but basically everything is working off a dimensional 45. So in the dimensional 120 realm, okay, and there's a reason for that mathematically when you're working with the compass. Even though it's not a full 360, you got 120, there's still the 45-degree vector that comes off of it. Okay, we don't call it 45 degree, but that's what it is. So in your three-phase, you still have those toggles 3 times. I wish I had another finger there, but anyway, at different points, and those frequencies are out of phase to where they're swimming and crossing. But very simple stuff. The what it boils down to is your potential plasma winding, and whatever you're quenching with, whether you're quenching it with air, pressurized air, oils, whatever medium you're quenching the plasma with to operate, the vacuum, removal of those things. Basically, when you're in parametric oscillation, you're into the plasma dimension of production from the magnetic electric field. And the whole thing is just like gear ratios. If a 1-to-1 gear ratio, if you have enough torque, works great. But if you don't have enough torque, then you got to spin that up, get the pressure up, and reduce those gear ratios. And so even with electricity, you have gear ratios and things. You gotta figure out what it is that you're wanting it to do, how much mass you're putting into motion, and those calculations are very easy to work with the emergency generation systems. The sympathetic resonance, I think I did a pretty good job yesterday of showing you how to come up with sympathetic resonance. That's really important, that you can design, no matter what it's receiving, that when it gets to to what it's doing, it'll receive all this information and everything else, but it sympathetically resonate within itself the cycles that you want it to resonate. So that's basically design. And I showed you the basic format to do that with, done right off the tractor and 360 and what we're after on that side of it. I want to talk to you just a little bit about what they call Geopolymers, and I'm convinced that a lot of the things that we're finding in the world were once Geopolymers, and I think the ancient what's known as ancient is actually state of the art today. It's just kind of hidden from us. And so when you understand that you can do geopolymers, pouring into place, pipelining into place, if you will, it makes construction a lot better. Now you just have to really get good at building forms and forming up those things. The geopolymer is really neat stuff, and getting to understand that, and then also getting to understand what's buoyant in this construct. Okay, I'm going to ask y'all a question, and in this construct, which is more buoyant, electrons, protons, or neutrons? Okay, and so anyway, fill in the blank below when you discover that, and let me know that you discovered it. Did a pretty good job of getting you to understand the 45-degree vector and the bipolar 9 switching, the 9 and 6 switching, and making the variant off of that. So we got more to dive into that, but the monopolar tapping into the construct is really what we're after. And what's really cool is the tripolar, okay? And so you have the monopole, the bipole, which we demonstrate bipole all the time, the tripolar effect, and how that tripolar effect increases the energy within the separation of media through the air in the construct. And then the hysteresis of the electric memory of where it's been, and the which leads us into the fuse progressive, if you will, activated carbon resistor. And so just like I was explaining, is with a battery, it's actually a resistor, and then when you finally get the back end of that to balance out, then the voltage comes up and brings the whole thing up to a potential. And once you understand the progressive resistance field, then the next step is figuring out the Henrys, if you will, that you're working with in the inductor. And those change when you wrap coils, and it also changes when you wrap different telemetries of coils, from round pi coil to a sympathetic resonant rectangular coil or triangular coil. There's so many different kinds of coil setups that you can do. I'm just now seeing that picture to paint in that field. So I hope I've painted a pretty good picture in 38, 39 minutes of what's going on. But the parametric oscillation part is when you're dealing with the plasma, and the plasma is pretty smart of what's going on in the field when you're asking to do something with your inductors. I'll be covering the VTA again in my wrap up, more about the electric and how to get it done, which leads us back to the electric. I use a thing called TLAR, and again, I'm a Sliderule, brought up in Sliderule world, and for pretty much 2-3 years ago, I got into the protractor world even more with geometries, and we'll get into more demonstrating the low pressure being amps and the high pressure being volts. We'll throw some Bernoulli in there for amplification. The difference in DC and pulse width modulation, the electric polarization. But we're going to get more acquainted with the reactive mirrored reflection and how that's important within the dielectric, dipole combination of the fields and the vectors, understanding more of the monopole telemetry, and the whether it's charged positively or negatively. If it's mostly charged positively, it looks like an eyeball, okay, in the asymmetric metronomic world. But we'll talk just a little bit about vector addition, vector subtraction, vector multiplication, and vector division. But the whole thing being the magnitude of the length of the system that you're wanting to build. And that's what it really boils down to, is where you tap into that oscillation. It works just like the hairpin circuit. And a lot of people, even though you got a potential and it's a hairpin of how that's vectoring off of that unit of being able to tap energy off that, even though the same wire, just when it makes a turn, how that works within the monopole bipole convergence. Okay, so then that's going to set the stage of leading us into radio frequency heating, and that happens above 70,000 hertz. It happens actually lower than that, but then you have two choices of that, whether you're choosing induction or dielectric. Okay, and dielectric is where it's at as far as the cooling side of it, and also understanding the well traps that you create with different frequencies within the same line. So they Z traps through there. So a lot of the hidden things that you see running right through the same line can have traps in there for potential energy further on down the line. And so understanding that matrix of heating and cooling and how that works in our construct, dealing with things like ultrasonic cavitation, sonoluminescence, those things. So I'm going to try to help discover for myself and others that are working on it, can we take rocks and what configuration do we need to have to lift those, and basically putting a small BB, if you will, into a big boulder and levitating that sucker. Okay. And I think it's possible. I've never actually seen it done, haven't done it myself, but I think Ed Lead Scallion knew how to tap into that. It had a whole lot to do with setting up the long fields that he did with his tripods to do that. He just knew how to take the DC and speed things up instead of reversing it. So I think that's going to be a pretty neat thing to make a discovery with, getting that side done. Like I said, I hadn't done it. I think it's possible, but we're gonna see. The ablation with radio frequency, a lot of things to work on through that, and understanding the different composites. The dimensional coil setups to create the monopolar bias is what we're setting up this record to be. And I still have the wrap up of this. Want to paint other picture, segue into teaching myself and getting feedback from the community of what we're working on. And it's just plain old hard work and research to boil this down to doing what we want it to do. I hope you guys enjoyed this presentation. And Jason, I know you're busy. I know you're probably working while you're listening to this, or driving, or doing other things. I'm thankful that you showed up. It does make me feel like I am talking to somebody instead of just talking to myself in the screen. I appreciate you stopping in. But if you have any questions, feedback, or anything, please shout it out, write it into the comments. I got to get busy. I got a full day. I got to make, we're having tomorrow at the Post, a luau. well, not tomorrow, actually, luau Saturday. And I have not been able to approach everybody that I wanted to approach to get the different funds to support our veterans, our homeless vets. If vet wants to have a home, trying to get that. It's amazing to me how many vets don't want a home. They like living on the street. But anyway, I got to go. If you're not having fun, you ought to, because we sure are. Y'all have a blessed day.